In this video, we're going to do an example using Gauss's law. And we're going to consider an inhomogeneous electric field through a flat surface. So we draw out our three axes, our x, our y, and our z, and we're going to consider that a flat surface lies in the xy plane and has dimensions given by a along the y-axis and b along the x-axis. So what is your unit normal vector of this surface? Well, it's pointing in the z direction, so it's z hat. Remember, the unit normal vector points perpendicular from the surface. The electric field we're going to consider is equal to c y squared z hat. So the electric field is also in the z hat direction, pointing in along the z axis. Here c is a constant. Since our surface lies in the xy plane, our infinitesimal area vector is given by dx dy z hat. Why is this? Well, it's x and y that is changing and that we're going to have to integrate over. Flux phi is equal to the surface integral of the dot product of our electric field and the infinitesimal area. So here we have a double integral. We integrate from 0 to a for y and from 0 to b for x. And we have the dot product of c y squared z hat and dx dy z hat. So what happens when you have the dot product of z hat dot z hat? Well, z hat dot z hat is equal to 1. If we were to have x hat dot z hat or x hat dot y hat, that would be equal to 0. So now we solve this integral. I'm going to solve it first for x. So we're going to be left with the integral from 0 to a of b c y squared dy. And then we do the integral for y. And when we do the y integral, we get y cubed over 3. And then substitute in for y equal to a. So the flux is equal to 1/3 of a cubed b c. And this is going to have units of Newton meter squared per coulomb.